All right, what we're going to do today is we're going to hinge the ailerons on the wing, uh, and I'm going to explain a little bit about hinges, wing types, and those kind of things. So we'll go ahead and get started with some explanation. Okay, so you got several different wing types, and I drew a couple here. So you've got, this is your flat bottom wing or Clark Y airfoil. It's a good all-purpose airfoil. It's high lift. It's good for a lot of airplanes, especially model airplanes beginning how to fly. A lot of full-scale airplanes use it too. And it's kind of a good all-around airfoil because it's got good low-speed characteristics, but it's also pretty draggy. Then you got your undercambered wing. You see this on, sometimes you see this on radio control sailplanes or free flight airplanes. This is a very high lift wing. Very low stall speed, but it's also very draggy. But the other interesting thing about this wing shape is, if you ever look at an airliner when they've got the leading edge slats and the flaps and everything extended, it looks a lot like that. So that's how they can land slow enough to not break anything. And when they retract it all and have a wing shape more like the symmetrical wing down here, they can go fast. So symmetrical wing is a little bit cleaner wing. It's got semi-symmetrical, doesn't have as much. Symmetrical means it's the same on top and bottom. Semi-symmetrical means it's not quite as much airfoil on the bottom. It's a faster wing. You see it on aerobatic airplanes. It'll fly upside down, and it's good for aerobatic airplanes. But our radio control airplane, our wing is closer to this. So, and then over here we've got hinge types. So on most full-scale airplanes, you have an aileron like this. So it's circular in the front of the aileron, but the hinge has to be on the radius of this semicircle. And the reason is that way this gap, which always trying to minimize, will stay the same all the time when the aileron's up or the aileron's down. But we can't do that easily. We need a different kind of hinge. We've got these cloth hinges, and our pivot point's going to be right here. So we have angled so that we can pivot right here without the aileron interfering with the wing. Now this also lets us do a gap seal really easy by we can put material in here to fill this gap that's flexible, and then no air can pass from underneath the wing through the hinge. Now the other thing we're going to do today is we're going to hinge. We're actually going to put the hinges in and the push rods for the ailerons, and this push rod or bell crank or whatever you want to call it looks kind of like this. So it's got a brass bushing, and then it's got a push rod inside of it. So now the thing is when this comes back, so when this is installed, you've got the push rod comes straight back in with the aileron, so it'll move the aileron up and down. The push rod comes straight out like this, towards the center where it's going to connect to the servo, and then it comes back at an angle. Well, why would it come back at an angle? Well, that's pretty straightforward. What we're really doing here is we're going to mechanically create differential ailerons. So if we got our servo and our servo wheel here, the servo is going to move about 45 degrees in either direction, which is going to be about this much. So if we look at that over here, and if this was drawn better, what we would see is that since this is curving up, it would actually move the aileron up more than it would move it down when it pulls it back, because you're going the same distance at the end point, but the degrees of arc is changing. So this might go 30% up more than it's going to go down. So that's where we do that. Now here's the example of how these things are hinged. This is the rudder, and that's how the hinge works, and that's why it doesn't pull away, is because it's angled. anyway, that's the little bit on what we're going to do today. We'll have some bits and pieces as we work our way through it. Alright, so this is the section we just finished. We put on, basically these are the part of the trailing edge of the wing and the aileron bell cranks or torque tubes to work the ailerons. You can see how they work. And the next step is we're going to put the ailerons, we're going to hinge the ailerons and get that all set up. And then we've got to, right about here, we're going to cut out for the servo and put a servo tray in. And then we're going to fiberglass the wing. Okay, so we put the aileron on and we've got the linkage. You can see it moving. And we put the hinges in. And we get this working. We're going to do this side next. So you can see we've got this piece in here. So this took a fair amount of work. One of the things we had to do was we had to cut the end here and trim it down. And you can see that, so we're getting close on the wing, and now we're going to do the other side, do it the same way. So we've pretty much finished up the wing. As you can see here, we've got fiberglass tape. We've fitted both ailerons. We cut out for the aileron servo. We've got the torque tubes in for the aileron linkage. Everything's all fitted. We've got these little plywood pieces on top of the wing, and those are for when we put the rubber bands on, so we don't crush the back of the wing. Basically, everything's slotted for the hinges, and we're ready to go. Other thing we did is when we fitted the ailerons, we fitted them up so that they match. There you go. You can see that we've got the ailerons matching the wing now. So anyway, we've done quite a bit of work. So the wing is essentially done for now. We're going to set it aside, and then we'll go back, and the next thing we got to do is work on the fuselage.